For an airplane to fly, the wings need to create an upward force which is called lift. It's also necessary for the airplane to be able to maneuver. The engine of the aircraft provides a forward force that is called thrust, which counteracts the force from air resistance, which is called drag. Unlike airplanes, birds generate thrust by pushing their wings against the air molecules. But airplanes and birds maneuver and generate lift the same way. More lift is achieved when air molecules flow faster across the wings. Suppose that the air around a wing is completely still. The air pressure from above and below the wing will cancel out, and there will be no net force. Now, suppose the wing is moving relative to the air. As air flows around the wing's shape forces the air above the wing to flow faster than the air below. The air below the wing is now creating a greater pressure than the air above, which creates a net upward force on the wing. This is one of the two reasons that lift is created. The second reason is that if we tilt the wings, the air molecules will generate an upward force when they bounce off the bottom part of the wing. The fact that air molecules generate a force when they bounce off a surface is also what allows an airplane to maneuver by using movable surfaces controlled by the pilot. These movable surfaces are what is called the rudder, the elevator, and the ailerons. The rudder controls what is called yaw. The elevator controls what we call pitch. And the ailerons control what is termed roll. When the aileron on one wing goes up, the aileron on the other wing goes down. When an airplane rolls, the force of lift created by the wings changes direction. A component of the lifting force is now pointed sideways, and this allows the airplane to turn and change direction. But when the direction of lift changes, it also decreases the component of the lifting force pointing upward. We need to compensate for this loss of lift in the upward direction during the airplane's roll, and we can do this by simultaneously controlling the airplane's pitch with the elevator. Changing the airplane's pitch with the elevator allows the pilot to change the strength of the lift that is produced. Changing the airplane's pitch changes the angle between the airplane's wings and the direction of the incoming air molecules. The angle between the wings and the direction of the incoming air molecules determines how much lift is created. If the force of lift is stronger than the force of gravity, the airplane's elevation increases. If the force of lift is weaker than the force of gravity, the airplane's elevation decreases. As we increase the angle of the wings relative to the direction of the incoming air molecules, the lift increases. However, there is a certain angle which will give the maximum lift possible, and if we increase the angle even further, the lift will decrease. If this happens, the airplane is in a stall, and the airplane will end up losing altitude. To recover from a stall, the nose of the airplane should be pointed downward, so as to decrease the angle between wings and the incoming airflow. The amount of incoming airflow can be altered by changing the airplane's speed. The faster an airplane is moving relative to the surrounding air, the more lift it generates. When it's time to land, the airplane's speed needs to be significantly reduced, and this is done by reducing the amount of thrust generated by the engine. This then also reduces the amount of lift generated, causing the airplane to lower altitude in preparation for the landing. However, right before the airplane is about to land, the speed may be so slow that the wings are not generating enough lift. We can increase the amount of lift being generated during landing by extending the wing flaps. Extending the wing flaps also significantly increases the amount of drag from the air resistance, causing the airplane to slow down more quickly. It's always desirable to land into the wind, so as to shorten the amount of runway necessary to stop the plane. It's also always desirable to take off into the wind, so that the incoming wind increases the airflow over the wings, thereby increasing the lift and shortening the amount of runway necessary to take off. Once airborne, the velocity of the airplane relative to the ground is determined by the velocity of the airplane relative to the surrounding air, plus the velocity of the wind relative to the ground. More information is available in the other videos on this channel.